In this video, I'll focus on angular momentum. Let me remind you linear momentum from our past lessons. I have a mass m moving at a velocity of v, and I know that the linear momentum of this object is m times v, the product of mass and velocity. Now let's define angular momentum. It's analog in rotational motion. I have a wheel or spinning object with a moment of inertia of I and angular velocity of omega. I can define the angular momentum L to be product of I, the moment of inertia, and omega, the angular velocity. Like P, which is mass times velocity. Here mass has a brother like I and velocity has a brother like angular velocity. The definition is very similar. And the SI unit for that is kilogram meter square per second. Why? Because I has a SI unit of kilogram meter square. Omega is measured in radian per second. We disregard radian as a physical quantity, or let's say physical real unit. So it's 1/second. So seems to be kilogram meter square per second. On the other hand, we shouldn't forget that L is really a vector. And do we necessarily consider its vector properties? In this lesson, no, just we mostly concentrate on the direction of rotation, let's say clockwise or counterclockwise. We do not actually go over the very complicated vector properties of that quantity for this lesson. Momentum format of kinetic energy. In linear motion, you remember kinetic energy is defined as a half of mv squared. Then I can multiply both upstairs and downstairs by mass. So it seems to be m squared v squared divided by 2m. mv is p, so it's p squared divided by 2m. Another format, let's say momentum format of kinetic energy. We have the same thing in rotational motion. Kinetic energy in rotational motion is a half of I omega squared. Then I multiply both upstairs and downstairs by I. So I have I squared omega squared divided by 2I. And then here L is I omega, so it seems like L squared over 2I. It's another, let's say, momentum format of kinetic energy in rotational motion. Now let's have a comparison. In linear motion, you remember I have force. In angular motion, I have torque. In linear motion, I have mass. In angular motion, I have I, moment of inertia. And here I can write Newton's second law as F equals ma in linear motion. In angular motion, I write it as I alpha, the product of moment of inertia and angular acceleration. Here I have momentum in linear motion. In angular motion, I have its analog angular momentum. And then P is equal to mv. On the other hand, L is equal to I omega, as we already mentioned. I can write the force in very generalized format in linear motion to be rate of change of momentum. Here is rate of change of angular momentum, the torque. And finally, kinetic energy, that's a half of mv squared or p squared over 2m. And kinetic energy in angular motion, a half of I omega squared or L squared divided by 2I. Let's answer this question. A flywheel in the shape of a solid cylinder, like a disc, of mass 7 kilogram and radius 0.1 meter rotates at an initial angular frequency of 80. Guys, here you know that the disc or cylinder has a moment of inertia of a half of mr squared. R is the radius and m is the mass. Okay, we know. Depending on the shape, you know I differs. So this is a specific formula we use for moment of inertia of a disc or cylinder. Angular frequency is another name of angular velocity, so it's omega. Find its angular momentum L and rotational kinetic energy EK. Okay, let's do it one by one. First L, I omega. Okay, I is supposed to be a half of mr squared regarding the cylindrical shape, and omega directly given in SI units. I plug in the values and I will get the L to be 2.8 kilogram meter square per second. This is L, the angular momentum. On the other hand, for kinetic energy, I have two options, a half of I omega squared, or if you like, you can use this result. It's L squared divided by 2I. As you wish, I use this one. L squared divided by 2I. Then I plug in the values. Just remember here, we should find the I because we need it. So let's say I is 7 divided by 2, 3.5, okay, times 0.01. This is 0.1 square. So it seems to be 0.035, sorry, it's I, okay? And downstairs you see that. And then this is the 2, and this is 2.8, the angular momentum we already found, to the power of 2. That's all, and it's the kinetic energy in SI units. Thank you for watching this video, and thank you for being with me with full attention. Next video will be about angular impulse. See you soon.